Okay, today we're going to do a lesson on complex numbers. So we're going to answer the question, what is a complex number and how can you add, subtract, multiply complex numbers? We're going to talk about multiply tomorrow. Today we're going to do the add and the subtract. The mathematical practice standard that we're going to be working on for the next couple of days is reasoning. And really what we're going to be talking about is we're going to go into this world of imaginary and complex numbers. So we're going to be talking about what the numbers and the symbols represent, because this is kind of a new topic for you guys. This is where we started with the I stuff the other day. And we're going to be talking about units, especially tomorrow. We're going to be talking more about units. All right, so we're going to look at the explore problems first here. In this lesson, you'll learn to perform operations with complex numbers, which have the form similar to linear binomials, such as 3x plus 4 and 2 minus x. So what they want us to do is add those two numbers up. I probably wouldn't do it the way they're doing it. I would probably just add them together the way they are, but they're asking us to group them first. So we're going to group those two together. We're going to group these two together. And then you're going to add the like terms. So 3 plus 2 is 5, and 4x minus x is 3x. All right, now we're going to subtract. So they want us to rewrite it as addition first. So they're going to distribute that through first. So it would be that double negative would go positive. And then, Ellie, you need to go get Daddy right now, okay? And then we're going to regroup. So we're going to put these two together. So negative 2, and we're going to put these two together. We get x. And we're going to go ahead and combine our like terms just like we did in the last one. So 3 minus 2 is 1, and 4x plus x is 5x. On these ones, we're now going to multiply them. We're going to use FOIL. So remember, FOIL is first, outside or outer, inner, last never fails as soon as I start the recorder. All right, so we're going to multiply our firsts together first. So 3 times 2 is 6. And then our outers would be 3 times negative x is negative 3x. And then we're going to multiply our inners. So 4x times 2 is 8x. And then our lasts, we're going to multiply 4x times negative x is negative 4x squared. Let me see, we made a little kitty cat there. And then I'm going to combine my like terms together, which usually means the centers get combined together. So negative 3 and positive 8 is 5x. And we've got a negative 4x squared. Okay, so we're going to reflect a little bit and kind of put this in the context of the imaginary numbers that we learned the other day. So in step A, you found that these two things equaled this. Suppose x equals I, the imaginary unit. What do you get? So if we substituted the I and we did 3 plus 4i plus 2 minus I, we would still get this same thing with the I substituted in instead. All right, in step B, you found that this equaled 1 plus 5x. Suppose x equals I, what do you get? So 3 plus 4i plus, they have a typo, don't they? Wasn't it supposed to be minus? Yeah, I think they've got a typo here. Minus 2 minus x. We found that it was, sorry, not x, I. We would find that it is 1 plus 5i. Is that what we got before? Yeah, it is. All right, then in step C, we found this. Let's go ahead and substitute in. What do we get, and how can we further simplify the right side of this equation? So we would get 3 plus 4i times 2 minus I equals 6 plus 5i minus 4i squared. We learned last week that I squared is equal to negative 1. So I'm just going to show the arithmetic. So we've got negative 1. Negative 4 times negative 1 would be positive 4. And then we would combine these two together. So 6 plus 4 is 10. So you'll only have this imaginary or complex answer whenever you have the i's in there. It would only have the two spots. You'd never end up with a trinomial because I squared is always going to come back and be negative 1. All right, we're going to go up to explain 2. It should be a little shorter today. So that way we can kind of just do these 2 sections, 3.2 and 3.3 this week. A complex number is any real number that can be written of the form a plus bi. So usually that's important. We should underline it. Where a and b are real numbers and I equals square root of -1, that just means that I squared equals -1. For any complex number, a plus bi, a is the real part and b is the imaginary part. Note that the imaginary part refers to the real multiplier of I. So really the imaginary part is the number that's in front of I. That's what that means. It does not refer to the imaginary number bi. The Venn diagram shows some examples of complex numbers. So the entire thing here is a complex number. Anything inside is a complex number. It could have a real part, an imaginary part. It could just have a real part. It could just have an imaginary part. If it fits in just the real part, we consider it a real number. And if it fits just in the imaginary part, it's an imaginary number. So we could say that it's an imaginary number and a complex number, or a real number and a complex number, or just a complex number. This right here, that's because the real number a can be, so the real number a is part of the complex numbers because we can always have a 0 in front of the I. Same thing with the imaginary numbers. You can always write it as 0 plus bi, so it always has they call the both parts to it. Okay. All right, so identify the real and imaginary parts of a given number, then tell which of the following sets of the numbers belongs to: real numbers, imaginary numbers, and complex. Big hint, they should all belong to that, right? All right, so in this right here, it says the real part is 9, so this is the real part. And then the imaginary part is 5. That's your imaginary part right there. Because both the real and the imaginary parts are non-zero, the numbers belong only to the set of complex numbers. Okay. So this right here, if it helps you, put a 0 in there for the missing piece. So 0 is the real part. The imaginary part is 7. Because the real part is 0, the number belongs to the sets. The imaginary and the complex. All right, now you've got to try it. I would pause the video and try it real quick. So let's see, this one here, I'd probably rewrite it as 0i. So we know that the real part is 11 and the imaginary part is 0. So since the real part is just the imaginary part is 0, it belongs to 2 sets of numbers. It belongs to it belongs to the real numbers and the complex numbers. So it's the real numbers and the complex numbers. And sorry, that's an R. All right, in the number 5 here, you have that the real part is -1. The imaginary part, remember, it's whatever the number is that's in front. There's always an invisible one. There's a 1. So it's only going to belong to the complex numbers because it has both parts to it. So complex numbers. Excuse me. So we're going to add and subtract complex numbers now. So to add or subtract complex numbers, add or subtract the real parts and the imaginary parts separately. So it's just like we did before. I probably would do this differently. I'm going to do it their way, and then when we get down to the try on your own, I'll show you the way I would do this a lot quicker. Where they want us to group the like terms together. So we're going to put the -7 and the 5 together, and the 2i and the -11i together. We're going to add those numbers. So -7 plus 5 is -2. And the i's are going to act like variables. So 2i minus 11i is -9i, and then we probably just drop the parentheses on it. Here we would want to distribute that through first, which is what they did here. So they got 18. They did it really weird, didn't they? Okay. So they missed their distribution through step. They didn't show that. So 18 plus 27i plus -2 plus 3i. They distributed in here, I guess. They swapped their signs here and then grouped it together is what they did. So 18 would be with -2, and then 27i would be up front with -3i. 18i minus 2 is 16, and then 27 minus 3 would be 24i. Okay, they want us to reflect a little bit. So is the sum of a plus bi plus a minus bi, where a and b are real numbers, a real number or an imaginary number? So let's just add them up and see what happens. So we know that a plus a would be 2a, and bi minus bi, wouldn't those cancel? So we only have the real part. So 2a is just the real part. So a plus bi plus a minus bi is a real number. It wouldn't be imaginary because the imaginary piece cancels. All right, let me show you the way I would do these. So I would probably kind of cheat a little bit on my distribution here. I would do what I showed you in that last one. Sorry, I clicked. I would distribute that in and go ahead and just swap my signs. And I know that's really, really poor notation to do that, but it's what I would probably do. And then I wouldn't rewrite it. I would just combine my like terms like I've been doing since, I don't know, 7th grade maybe. So 17 minus 9. 17 minus 9 is 8. And then I would put together the -6 and the -10 with -16i. It's literally one line of work. So you're going to write your problem out. Actually, you don't even have to because you're doing your work in the book. So I would show my steps in there at least and then write the answer. Here, it's an add problem. So I would just add my like terms together. So 6 minus 8 is 8. And then 17i and -12i is +5i. All right, and then that's it for what we're going to do today. So today was really quick, short, and sweet here. Excuse me. Okay, so to finish up today's notes, you should get this done here in class because you're going to get tons of time to do it. I want you to elaborate 14, 15, and 17. We'll save 16 for tomorrow because it talks about multiplying.